Welcome to Horsepower. I'm Willie, and today we're going to continue progress on the 5S GTE beam Celica, and we're going to get balls deep in fabrication.
We start off this episode with the cooling system. The radiator I'm going to be using is from the Toyota Supra Mark IV. It happens to be the right height. We have the inlet and the outlet in the right place. Unfortunately, it was too wide, so I had to trim 100 mm off it. This is far easier than getting a custom one made. The other important part of the cooling system is, of course, the intercooler. And now this core is a rather difficult size to find, so I had to get one out of China. And this is to suit a GT86. Unfortunately, the end tanks are not going to work, so I had to modify those.
I've got the intercooler and the radiator both all mounted up where they're pretty much going to go. And this is just sitting there, so that's a bit wobbly, but the radiator is where it's going to be. So I've already done this little mount here. And now it's time to do this one here. It's obviously important that this is going to be rubber mounted. If it's hard mounted to the chassis, it's going to flex the radiator and basically make it fall to bits in no time at all. So what I've done here is just got some aluminium sort of angle iron or angle bar sort of stuff, and basically I just need to weld that to the radiator so it's all sort of set up in place. I'll grab the TIG, give it a couple of tacks, pull it off and weld it up.
It's time to start thinking ahead and organise the manifold flange. You can easily get off-the-shelf flanges for the 3S GTE beams. However, none of them use these extra holes I want to use, so I've got to draw up my own. So we'll come across here to my computer. Looks like a whole mess of just absolute garbage there at the moment, but you can see some holes. Finish that sketch, and then I'll bring the next layer on, and so that will then be sent off to the laser cutters to get a nice stainless manifold cut out of that. The manifold is underway. I've made the first collector here, which is a pretty simple 2-into-1. So this is going to be a twin scroll manifold. I should probably mention what turbo I'm using. So it is a Borg-Warner EFR 6758, and this is the same turbo that I used on my last 3S GTE. It really is an amazing turbo. The way that it responds and makes, what it'll make, 400 wheel horsepower, 300 wheel kilowatts, and it's just perfect for a rally car, really, just a really wide spread of power. And so I'm making this out of stainless 304, which is kind of the standard. I think the fashion these days is a 321 grade, but it's probably, well, it's definitely a bit hard to find around here, but this will work just fine. So there might be a bit of debate, not for me, but I've talked to a few people and there's a few different ideas about runner size. So this is 1.25 inches, and the other option would be 1.5 inches to go slightly bigger, which is this size over here, so quite significantly bigger. If you look at the size of the ports, this is actually closer like volume area size, so one might think it might be best to use that. However, I did a bit of research and there was a lot of good information on the Morrison Fabrication website, and they do a lot of stuff for Evos, and they did this dyno test of a 2.1 litre Evo, which is very similar to this engine, and they found that the smaller runner had so much more boost response. so much more torque down low and still flowed sort of well over 800 wheel horsepower. And they kind of thought, well, you might guess that the bigger runner would give it more power up top, but it really didn't, not with their test anyway. So for me it's a no-brainer to use the smaller stuff. Even if it does get choked up a little bit up top, I'm happy to sacrifice that for a bit of low down torque and response, which is what this motor is all about. And it's a twin scroll turbo, so with a 4-cylinder we want 1 and 4 going to either port, and then 2 and 3 going to 1. So after a bit of thinking and designing in my head, what I've decided to do is take 1 and 4 and then bring them both up and then into these 2 ports, and then these 2 will come down underneath and then come up, and that one there will come round and come up into this port here. So now it's just a matter of you can see all the little bits I've got here, chopping up little bits and make them all fit together. I've got the manifold all tacked together, pretty happy with how it looks. The only thing I'm not happy with is how close that is to that cam sensor, so we don't want that getting too hot. So currently it's going to cook it, so I'm going to do my best to try and reroute it just so it doesn't sit quite so close. Otherwise I'm really happy with it. You can get to all the nuts and bolts, maybe for the exception of that one there, pretty easily. Now I've modified that pipe a little bit so there's a bit more clearance to that sensor. Probably what I'll do is put some kind of heat shield around this area to try and keep the heat away from that. But that's all mocked up, all tacked, ready to weld together. So the next step is to think ahead about how we're going to weld it. The order in which each weld is done is very critical. Obviously we can't get to all of these welds while it's in a piece like this, so the plan is to basically weld together all of these welds as best we can get to, except for a few strategic ones which we just leave tacked together. I'll then break those tacks, pull it apart, or weld up the rest of it and then put it back together and then finish the last few welds. As this is stainless, it's best to back purge this with argon. I don't feel like this is totally necessary and you can get away with not doing it. Exhaust gas after all is an inert gas and doesn't corrode the material. However, there is a lot of heat going through it, and when you get elevated heat in a material, it tends to corrode fast. So if you want the utmost in reliability, it's definitely the way to go. It's now time to start fully welding these up. Got my purge line in there, stuffed in with a bit of aluminium foil. Run that off a separate regulator or separate bottle up there. It's quite handy having two. So basically it's feeding into this port here, so these two are separated obviously, so we just got to be careful to do cylinders 2 and 3, so that one and that one. And I'm going to not do that one yet and basically fully weld everything else except for the flange ones, and then take that out, put it into the other one, and do it all again. So putting all these together I think is a bit more of an art than a science. That's sort of the way I do it anyway. There's a lot of trial and error, chopping, shaping, grinding, imagining things in your head, putting them together, see how they work, realise that was a shit idea, start it again. And it's just a whole lot of playing really, and it's actually quite fun. And you can make some pretty cool looking things. They're not perfectly equal length, although they aren't far away. Now that I've mostly got it welded up on the outside easy to get bits, it's time to break off these tacks and pull it apart and weld the bits we can't get to. Now that I've got all the pipes welded up, I put them all back together and set them back up on the flanges. So all the hard bits are welded. Now it's the easy bits around these bits here. I've got to do a bit of shaping there to get that nice and smooth. Once I've welded the outside, we'll go around and weld the inside as well to get all the transitions nice and smooth. Right, now the manifold is fully welded. Usually what will happen when you weld the flange is it'll warp. So I've chucked it on the linisher and put a nice flat edge on there, as well as the turbo face. So the next wee stage is just to tidy up. So I'll get the die grinder and just smooth out these ports a little bit, just make the airflow a bit nicer, and then grind back some of these tacks here and there. And then the final thing will be to put a pressure sensor port on it. So with this I want to be able to measure exhaust manifold pressure, more just out of curiosity's sake than anything else. So I need to find a suitable place, maybe just here. Yeah, just for testing purposes. We'll put it on the dyno, see what the exhaust pressure is. I don't really know what I'll do with that information. If it's astronomical, you might look at changing out your turbo. But I'm just interested to know really, and it'll be one of those things I don't regret doing. And obviously I need to tap these holes here to accept the studs. There is the turbo all bolted in. It's just sitting there, just with a couple of bolts in there so I can fab up the intercooler piping. Unfortunately, I did make a bit of a fuck up. If you can see from this angle here, it's quite obvious that it's on a big angle. And it's not an easy thing to fix. So I'm pretty pissed off about that. But I'm not going to fix it, I'm just going to deal with it. I have got a solution to make it look better. Obviously it's not going to have any effect on how it works or anything. So what I'm going to do is put a heat shield on here, and I'll make the heat shield square, which will cover up this flange. And no one will ever know. Right, now time to move on to the intercooler piping. So I'm I'm just going to use an ordinary silicone joiner here. I wouldn't mind using one of like the Wiggins style clamps, which are quite nice. However, I don't want to weld to the throttle body. I could do if I take it all apart, but I actually can't be asked doing that. It's just a strange, and it's also a strange size. So it actually, I've machined up a little like cone step down from like 2.75 inches roughly down to 2.5, and then it's basically a straight shot here to the top of the intercooler. And I've done something a little bit different here. You could just go for like a straight pipe into it. What I've done is I've made this up. So this is basically made from two 90-degree bends that are chopped up and welded together, and so that'll sit on there like that, and I think that looks really cool actually. I'm pretty stoked with that. I really like the style, and it should help disperse the air a bit more evenly into the whole core. And then what I'm doing at the bottom is this. So again, rather than just have a pipe go straight into the bottom, I'm going to use this, and that's going to weld on there, and then I'll have to do some pipe work afterwards to mount it up to the turbo, but a very short pipe. That's a cool thing about this setup, is it's has very little intercooler piping, so very little chance of failure, and gives a really nice elegant look to the engine bay. We've got a lot of area of cooling in the front here. With like a transverse motor, the main rails are quite far apart, so it gives you a lot of width. Unfortunately the headlights do complicate things a little bit. So this side-by-side intercooler radiator setup I've used for the past few years, and it works pretty well. The cool thing without having a front mount is your radiator gets nice clean airflow all the time, so it hasn't already been warmed up going through a radiator. So, and then the whole packaging in terms of nice tight intercooler piping, then this is sort of quite a nice way of doing it, I found. I did consider doing the old classic front mount with this, but I quite like this setup. And it's actually a reasonably sized radiator on there, and the radiator is actually bigger than the factory radiator despite being shorter. So obviously, because I've dropped this down, I've added an extra 75mm to the height, so the overall area is actually bigger than the factory ST185 radiator, and then managed to squeeze that in there, which is also reasonable sized. So yeah, I've got to make some holes in the bottom radiator and weld that on. This is the intercooler all ready to go. Here's the inlet pipe. So I'll give this a bit of a clean up. Well, everything needs a really good clean up when we're welding aluminium. That'll go in there. I've left a bit of material there just to give it a bit more integrity. There's a bit of pressure going through here, and yeah, you want to keep it as strong as possible. And then this is obviously the original inlet, so blank that up. And then at the top here, I made another wee blanking plate. So that'll go just like that. And then the outlet, which I just showed you just before. So now we want to give everything a real good clean up. When you're welding aluminium, you can't get it too clean, so we'll do that and then start welding it. There is the intercooler piping all completed. So we've got our double hump silicone joiner here. That'll just mean that it can compress and expand quite a lot as the motor's going to shake that way, it's going to come forward and back, so like a Wiggins style clamp won't have enough movement in it. So pretty simple, 1, 2, 3, 4 bits all weld together. Looks pretty sweet. And then down here we have the wee pipe from the turbo to the intercooler. Nice short piece of piping. So it's all solid here, no silicone joiners. We've got these straight out of China, genuine Epman Wiggins style clamp things. So there's going to be less movement down here, so the motor will still shake, but there won't be any forward or back much. It'll be sort of wobbling like that, so that should work pretty well for this little pipe. And so obviously all the radiator is welded up and it all worked out really nicely. This pipe here, sort of intake, should distribute the air nice and evenly to the whole core. Also welded on another little lug here for the final little rubber isolator mount thing, which I need to go and get. I don't have one yet. So the next stage, what I'm going to do is, because I want to go down to the ceramic coaters and take my whole lot of stuff to both ceramic coat and powder coat, is a heat shield for the turbine here, and a heat shield for the sensor to come around here. Here is some heat shielding all done. It's simply just some 1.6mm or 1.2mm mild steel rolled round, shaped, some holes, and then it's got a piece in here just to help trap the air in there, keep all the heat in there and not everywhere else. Plus it looks nice and square now, so nobody will know if the sun's going on underneath. And then over here, got a heat shield here which will hopefully go some way to helping this cam sensor here. It might still get too hot, we'll just have to wait and see. But yeah, that's just 3 bolts welded to the manifold and 3 nuts holding it on. It's pretty simple, and hopefully that works. That's all for today, folks. Thanks for watching. In the next episode, we'll get this beast up and running. See you then.